Okay, today is Sunday. We're getting ready to start our next week in school, only 2 weeks until fall break. And I'm going to do 3 or 4 videos to finish up this unit. The first one is going to be on generating Pascal's triangle. Now, this is not anything you're going to be tested over. This is something that you may see in on an ACT, and I'll show you why in just a minute. But this was created years and years ago with Blaise Pascal, and it's just a number pattern. I'm sure you've heard of Fibonacci's series. That's a number pattern. This is also a number pattern. And it basically forms a triangle like that. So what we are going to look at is how do we generate this tree. And if you notice, there are 2 paths that you can take. You can either go to the left or you can go to the right. And that means there's only one path to go here and only one path to go here. Then when we get to this one, well, great, my Mobi is not working right now, so we're just gonna do this up here. Okay, so when we get here, there are actually 2 paths and 2 paths when you get here, 2, 2, 2. And we're just going to recreate this by summing the paths that you get here. There's always going to be a 1 on the outside there, but when we add those, we get 3. When we add the 2 and the 1, we get 3. And then there's a 1 on the outside because there's only one path going down. So that's our pattern to do this. Add these and I get 6, add those and I get 4 and 1, then 1, 5, 10, 10, 5, and 1, 1, 6, 15, 20, 15, 6, and 1. So hopefully you see the pattern there. 1 is always on the outside, and then you sum these, and what else do you notice? These are the same. The closest to the outside are the same, closest to the outside, and then they're the same there. So then that's kind of how you create that triangle. So keep that. And let's see if we can get to the next page. Okay, so you should have this completed in front of you, and it says, what's the value in the first and the last? It's 1 for every other node. The value in the node is the sum of the 2 values above it. And then it said go back and fill in rows 5 and 6, which we did already. All right. Here is why we do this, because this says relating this. When you multiply out terms, like if you had a plus b squared, well, you would know that you could actually FOIL that and get a squared plus 2ab plus b squared. We could also do that with a plus b cubed, or x plus y to the 4th, or 2x plus 4y to the 5th. You can just always FOIL 2 of those together. And this is wanting us to expand these powers. So a plus b to the 0 power, that's always 1. Anything to the 1 power is the quantity itself. We've already done this one. A squared plus 2ab plus b squared. I want y'all to go ahead and work on finishing those, and I'm going to recreate the triangle up here while y'all are doing that. Okay. So for this one, let's see. I'm going to do this right here off the top of my head. What is that? A cubed plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed. Okay, so we have a cubed plus 2a squared b, 3a squared b. I'm going to add those